Okay, so the answer to this is going to be, first of all, 0.4 grams is how many moles of lead iodide. So, first of all, step number one, it's going to be 0.4 divided by the mass of lead iodide. Now, lead, if you look at the periodic table, 207 has a mass of 207. So it's 207 plus 127 and another 127 because it's PbI2. So that works out to be 461. So write out each step, and also you need to put it in your calculator, obviously, but write out each step so you know exactly what each amount is. So here you're going to have 8.67 times 10 to the minus 4, and that's moles. We'll keep it below the lead iodide, so this is obviously moles of lead iodide. Now, if you look at the number of moles of the other two, it will be the same. It will be the same for lead nitrate, 0.67 times 10 to the minus 4 moles. But for the other chemical, which is potassium iodide, it needs to be double. So you simply take your answer on the calculator and double it. So it's going to work out to be 1.74 times 10 to the minus 3 moles, and that corresponds to potassium iodide. This corresponds to lead nitrate. Now, mass is Mr. Mole, so you've got a number of moles. You need to work out the mass involved. So here, mass is this number here. So let's actually write it as 1.74 times 10 to the minus 3 times the molar mass of potassium iodide, which is 166, which is just above, so 166. Okay, now work that out in the calculator, and you should get 0.28. Let's write the answer in red. So 0.28 grams of potassium iodide. For lead nitrate, it's going to be 8.67 times 10 to the minus 4, and that's going to be multiplied by the molar mass of lead nitrate, which is 186, and that works out to be 0.16. Now it's worth that doing as a double check. 0.16 plus 0.28 gives you 0.44, so that's very close to 0.4. So really, these are the amounts you have to add of these two chemicals so that you won't really have a limiting reagent or excess. It's just enough to give you 0.4 grams of potassium iodide.